We will begin by looking at place value and how they connect to the various math operations of adding, subtracting, and then multiplying and dividing. But before we get into place value, let's review a little bit about the different types of numbers that we can work with in mathematics. Now, we should all be familiar with a number line. So somewhere on this number line, I'm going to go ahead and put 0. Right, so then with respect to 0, on the tick marks going this way, I can write 1, 2, 3, 4, 5, and so on. If I look at the numbers 1, 2, 3, 4, 5, and so on, those numbers are referred to as the counting numbers, or sometimes they're referred to as the natural numbers. And it's the first set of numbers that we normally work with. If you take the counting numbers and then we include the 0, that set is referred to as the whole numbers. So those are going to be the types of numbers that we first look at when we look at mathematical operations. Now over here to the left of 0, the numbers that would exist over here would be referred to as the negative numbers. And we will start looking at negative numbers or signed numbers a little bit later. 0 is not considered positive or negative. It is the dividing line between the two sets of numbers. Now sometimes on the positive numbers we can put a little plus in front of them to indicate they're positive, but normally we leave that little sign off and we just assume when we look at a number, if there's not a little negative dash in front of it, that the number that we're looking at is positive. Again, assuming that the number is not 0, because 0 doesn't have a sign. It's not positive nor negative. Now, in between these counting numbers, in this little space that would exist between them, there's where we get into numbers that would be represented with a fraction or a decimal. So those are typically referred to as the rational numbers, if it can be written as a fraction. If the number cannot be written as a fraction, it's actually called irrational. And we're going to be dealing with those types of numbers also a little bit later on. Now every number, as long as it's part of the real number system, would have a place on this number line. Now you might wonder, well, what sorts of numbers would not be part of the real number system? Those get into complex numbers. They involve the imaginary unit. We're not going to focus on those right now. We're just going to be looking at real numbers. To start with, we're just going to be looking at the whole numbers, and then later on we'll move into looking at negative numbers and then all the stuff in between here, the rational numbers, and how do we do operations with them, add, subtract, multiply, and divide. But every number, as long as it's part of the real number system, has a spot on this number line, and how we can determine its position and where it goes, we start looking at this idea about place value. All right, so when we look at place value gets into that the position that a digit is in a number is special, and it tells us about how big or how small that number is. So for instance, I have this number written down. It's 1, 784, 653, 201, 459. So it's commonplace when we write our numbers to maybe put commas in every set of 3, because every time we move over a set of 3, we introduce new language about what's going on in that place value. So when we write a number, this spot that's going to be furthest to the right is our ones spot, which is also sometimes called the units. Moving over position, that next spot is our tens. And then the next position after that gets into our hundreds. All right, so then moving over from the position from that, this number that would be the fourth position over from the right gets into the thousands. And then the next position after that would be the 10,000s. And the next position after that, it would be the 100,000s. So we kind of repeat the language that we used in that first set every time we move over to the next set of 3. So 100,000s. All right, so then when we move over to this next position, we get into our millions. Okay, and then we're going to repeat the pattern that we would have our tens of millions and then hundreds of millions. And then when we get to the next set of 3, we refer to that in the billions. All right, and then we would have 10 billions and 100 billions as we move over, and then when we move over to the next set of 3, we get into the trillions. And we can keep going in this fashion. Our number system is considered to be called a base 10 system because we group our numbers into sets of 10. So every time we move over in position, we get another power in our 10s. So what would be in the ones spot right here, this would be 10 to the 0th power. If some number is in the 10 spot, that would be 10 to the 1st power. If a number is in the 100 spot, that would be 10 to the 2nd power. When we get into the 1000 spot, this would be 10 to the 3rd power. And then again, we introduce new language every time we get to a set of 3. So then when we get to 10 to the 6th power, so adding another 3 onto the 10 to the 3rd power, there's where we get into our millions. Billions is the name when we get to the next set of 10, or sorry, the next set of 3, so 10 to the 9th power. And then the trillions then would be 10 to the 12th power. All right, so these exponent notations tell us how many zeros would fall after the 1. So for instance, 10 squared, or 10 to the 2nd power, would be 1 followed by 2 zeros. So there's your kind of your hundreds. And here's a fun fact. The number Google, now this is not spelled like the search engine, this is G-O-O-G-O-L, but this is actually a number. And this number is 10 to the 100th power. All right, so that would be 1 followed by 100 zeros. Okay, so that's actually a number out there. So new fun fact for you. Okay, so the whole point of the place value is that where a number is written in the position it takes in a larger number matters, and it also impacts how we say that number. So for instance, this number right here would be 1,784,653,201,459. All right, so definitely kind of a long number to say. Trillions is not the last number. We can keep going over here to the left. Just those place values are a little bit more uncommonly used. If you wanted to know what positions are over here, you could definitely do a search for that. But we could keep going to the left over here. Now, after the 1 spot, we can put a decimal point right here, and we can actually continue this number over here to the right. That's when we get into decimal numbers, which will be explored later. All right, but just in terms of place value and how that connects to a number, so we're going to write these numbers in words and also in what's called expanded form. So for this first example, I have a 5 and a 4. So that number would be said in words as 54. Now when we go to write this in what's called expanded form, the only thing that's nice about expanded form is it allows us to see how a position that the number is, or its place value, how it connects to the power of 10. So for this number, if I wanted to write it in expanded form, I could write this as 50 plus 4. Okay, so then I have this idea that this 5 is in the 10 spot, and then this 4 was in my 1 spot. Right, so just as another example about writing a number in words and also how we would write it in expanded form. So the next number is 93205. It's not wrong to write the number without the comma, but the commas grouping every set of 3 helps people break apart the number and be able to kind of see those sets of 3 easily, because then that helps us understand what that number is, how big it is, and maybe how to say it. So this one would be said in words. It would be 93 and then 1,000. Okay, so when I kind of stop right here, I kind of say this part as if that was the only number, and then I say 1,000 because the 3 ends in the 1,000 spot. And then 205. Now we would not say 205. Okay, we don't throw the word and in there. The and is used when we say a number in a very special spot. The and is used where there would be a decimal point. So these are used for saying decimal numbers. So we don't throw an and in a number unless we're using it as for the decimal point. So it would be inappropriate for this number to say 93,205. We would just say 205. Now to write this in expanded form, so this 9 is in my 10,000 spot, so I could write 90,000 plus 3,000, because the 3 is in the 1,000 spot, plus 200 plus, and I don't have anything in the 10 spot, so I can skip that, and then I can just write my 5. Okay, so there's where I can write this thing in expanded form. Sometimes, for the expanded form, really to stress the power of 10, we can actually write these with the powers of 10 behind it. I'll just show you one just so you can kind of see it. So this 90,000, because that 9 is in the 10,000 spot, we could write this as 9, then times 10 to the 4th power, right? So this is 9 followed by 4 zeros. Since the 3 is in the 1,000 spot, we can write that as 3 times 10 to the 3rd power, so that's 3 followed by 3 zeros. The 200 I could write as 2 times 10 to the 2nd power, or 2 followed by 2 zeros. And the 5, because it's in the unit spot, I can write that as 5 times 10 to the 0th power. Anything raised to the 0th power is 1, so this is just a fancy way of writing 1. Having a good understanding about numbers and their place value helps us when we get into doing operations on these numbers involving adding, subtracting, multiplying, and dividing. And it also is important that we know how to say these numbers to other people, and that we understand that the position that the digit is in, or its place value, has significant meaning for us.